Welcome to Team Repicked's process review. Our team's process began during our January experience where we were taught to think differently, to look beyond the obvious solutions to seemingly obvious problems, and to apply this mindset to creating truly inventive and innovative creations. The steps we followed from opportunity recognition through our prototype pitch are captured as part of the generic product development process, or PDP, with many of the process steps taking place within the concept development phase. To begin product planning, the team identified pain points by capturing and reviewing personal videos, thinking about frustrations and hobbies, reading about opportunities in media, and prompting AI for unmet market needs. The team then used multi-voting, a weighted voting system to avoid majority rulings, to narrow down their areas of opportunity from identified pain points. After defining criteria which would guide the team's opportunity selection, a mathematical decision tool called Analytic Hierarchy Process, or AHP, was used to determine the top 3 opportunities in accordance with the defined criteria. Through this, the team chose to pursue a better method of clearing snow off the top of vehicles. The next step in the PDP is to create a problem statement and a mission statement. Each team member generated individual problem statements, common themes were identified from all of the individual problem statements, and multi-voting was again used to select the team's most important theme, safety. From the problem statement, a mission statement was developed outlining anticipated stakeholders, constraints, business goals, and of course, the primary directive of the product. After an initial draft, leveraging feedback the team received, the mission and problem statements were revised to their near final form. The next step was to identify customer needs, which kicked off the concept development phase of the PDP. Our step 0 was to first personally identify all needs that a customer could potentially require, whether they knew it or not. Next, the team developed an interview template, and each team member reached out to a minimum of 2 potential customers for in-person interviews, as well as taking the time to interview an AI model to see if there were any further insights to be gained. After the interviews, customer statements were interpreted into raw needs. The team began with 316, but after creating a customer needs hierarchy, this was distilled down to 9 primary needs and around 170 secondary needs. The next step in concept development was to set metrics and target specifications. The team first had to further combine and reduce customer needs to make working with them manageable. From here, a metric was created to measure each of the 29 remaining customer needs. With defined metrics, the team then gathered examples of existing snow products and benchmarked them, ensuring to cover a range of products from a simple snow brush to more novel products like electric blowers or car covers. Following benchmarking, a star rating from 1 to 5, with 1 being the worst, was assigned to each product on how well they met customer needs. These star ratings were then graphed on a spider chart to visually depict how each item compared to each other. The thick red line represents the ideal specifications, which the team identified when setting the marginal values and ideal values for each developed metric. Next, the team researched what potential products were already patented. This was done through the U.S. Patent Office's website. Initially relevant patent classification definitions were found, which then aided in the retrieval of issued patents and patent applications. It was now time to generate concepts as part of concept development. There were several tools at our disposal. Functional decomposition let us break down the large problem of clearing snow and ice from a covered vehicle to reaching snow and ice, removing snow and ice, and storing the removal tool after use. Another tool used was trees, which suggests methods to solve contradictions in developing a concept such as the need to preserve energy while improving productivity, or the need to create a very long object while preserving stability. Biomimicry was used, and while it did not produce many ideas, it produced very unique ideas. The team's preferred method was bisociation, the act of taking a random stimulus and applying all knowledge of that stimulus to the problem at hand. This technique not only promoted a large amount of ideas, but also promoted creative ideas, which were not obvious during benchmarking or patent searches. Finally, a systemic approach was taken to concept generation. Concept classification trees were used to break solutions to problems down to their most basic forms, with inviable branches being pruned. Many of these ideas then fed a concept combination table, where an item from each column was chosen, resulting in even further concepts being generated, such as a foldable snow and ice scraper from the combination 167, extendable handle, sweeper, hinged. With many concepts now generated, it was time to make a concept selection. Multi-voting was used to align on 16 concepts, which would proceed through further screening. First, a concept screening matrix was prepared with selection criteria and a reference product. All selected concepts were then compared against the reference. Based on the sum of pluses, zeros, and minuses, products were given a net score and ranked. Ideas which scored lower were combined with aspects of other concepts, and 5 concepts were chosen to move to concept scoring. The first step of concept scoring was to create a different set of selection criteria to differentiate concept attributes. The importance weight for these criteria was generated using AHP. Similar to concept screening, a selection matrix was prepared with selection criteria and the reference product. Concepts were then scored against the reference on a scale of 1 to 5, where 1 is way worse, 3 is the same, and 5 is way better than the reference product. Using the importance weighting, weighted scores are determined for each concept. The team determined that the top 2 scoring concepts were novel enough to proceed to prototyping without any further combinations or improvements: salt, de-icing capsules, and extendable heat and clear. It should be noted, following concept selection, a final revision was made to our problem statement, as the concept development phase helped focus our product further as our concepts began to converge on potential solutions. With concepts in hand, the team began working on prototyping by leveraging the 4-step process listed in the course textbook: product design and development. First, prototypes for the salt and de-ice capsule were created using dishwasher pods on a crushed ice in freezer to determine if polyvinyl alcohol would dissolve in cold conditions. A second prototype using gelatin capsules on ice was created to determine if gelatin would dissolve in cold conditions. These form the salt and de-icing capsule concept tests, which showed neither material dissolved quick enough to be viable without further research, leading to the concept being shelved. The team then moved on to creating a prototype for the heat and clear to determine how hot silicon would get if placed directly next to a heat source. This was accomplished by heating a pan on a stove, then placing a silicon mat on the bottom of the pan to see if heat could be felt through it. A large amount of heat was felt without melting the silicon or burning the user, indicating this was a viable concept. The team's last prototype was to determine how much weight was reasonable for a person to move at the end of a long handle. This was accomplished by tying increasing weight to an extendable handle and asking men and women to attempt movement at different weights and lengths. This helped the team determine the target brush head weight should be less than 3 pounds. To pull the project together, a pitch was created for the heat and clear CM1. The team's final concept, which is thought to be viable and even made the team excited while developing the pitch. Following an NABC mindset with influences by the Pixar pitch, the team attempted to touch on emotions while showcasing the market segment the product can fill. Upon reflecting on the process and results, the team has come to appreciate the work upstream which created the products we support daily. There were many tools our team was exposed to which we were unaware of and hope to see leveraged in our professional lives in the future. During this process, there was constant need to check in with ourselves on the problem statement and mission statements to ensure we were keeping ourselves honest while cross-functionally vetting our various concepts and ideas. Ultimately, our team would like to note that we believe our lack of chemical engineering experience prevented the de-icing capsule from being more thoroughly vetted, as we believe it is truly a novel, marketable product. Thank you.